Thermodynamics. Thermo means heat energy, dynamics means work. It is a macro science derived from human experiences which deals with conservation of energy in a container. This is surrounding, this is the system. Then comes thermodynamics. It is of two types, systems and surrounding. Anything that is under observation is called system. Anything around the system is called its surrounding. Note: observations are made from surrounding only. We never go inside the system. What is a wall? The wall or the boundary can separate the system from the surrounding. Wall can be real, imaginary. Wall can be stretchable, unstretchable. Wall can be rigid, flexible. Wall diathermic, which allows heat transfers. In हिंदी जो heat को transfer होने दे. Adiabatic does not allows heat transfer between the system and the surrounding. और हिंदी जो heat को transfer ना होने दे. System. Closed system, open system, isolated system. Closed system which can exchange energy but not mass with surrounding. Example, open flask. Open system which can exchange both energy and mass with surrounding. Example, water bottle. Closed. Water bottle is a closed example of open system. Isolated system which neither exchange energy nor matter with surrounding. A thermos and a universe is a perfect example of isolated system. Ratio of extensive property is equal to intensive property. For example, density is equal to mass by volume. Mass is an extensive and volume is an extensive property. If A and B are extensive property, A plus B is equal to extensive property. A minus B extensive, A into B extensive, A by B is equal to intensive. How to identify between intensive and extensive properties? Technique 1. Ratio gives intensive property. Mass by volume gives density, that is an intensive property. Moles upon volume. Extensive by extensive gives intensive. Technique 2, which is also known as Cartner. P1, we will take two blocks and suppose the pressure of the container A is P, volume is V, T, temperature is T, and number of moles is equal to N. And we will half thing. Now new volume will be V by 2, pressure will be P only, temperature will be T, and is equal to N by 2. If on dividing system the quantity changes, extensive or if remains same, intensive. Important points: all the concentration terms are intensive, all temperature of a substance are intensive, all the energy terms are extensive, enthalpy, entropy, Griff's energy are extensive, all equilibrium terms are constant, any property with prefix or per mole specific are intensive, refractive index intensive, function, state path, state, those which are dependent on initial state or final state only and independent of path taken. Example, temperature, AQI, displacement, path only dependent on initial and final state and dependent of part taken. Example, work, heat, capacity. What is, how can we define work? Work done is equal to W is equal to minus P external delta V, or dW for a small change of work. dW is equal to minus P integration of P external dV. P or V का कुछ रिलेशन देगा होगा हो तब P external is equal to pressure delta V equal to V2 minus V1. State of a system, state P, V, and RT. State variables are P, V, and RT. They tell us about the condition of the system. N1. State is changed to N2. Thermodynamics process is occurred. If state variable is changed, then state is changed of the system. This is a thermodynamics process. Zeroth law of thermodynamics. If A, B are in thermal equilibrium, B, C are in thermal equilibrium, then A, C are also in thermal equilibrium. SI unit joules, CGS unit hours. 1 joule is equal to 10 to the power 7 hertz. 1 calorie is equal to 4.186 joule. 1 liter ATM is equal to 12.3 joule. Important one conversion. 1 bar is equal to 100 liter. 1 bar liter is equal to 100 joule. Compression of gas. Compression delta V is equal to V2 minus V1. W is equal to minus P external delta V. Delta V is negative. So work done by compression is equal to positive on the system. Expansion of gas on expansion delta V is equal to V2 minus V1. W is equal to minus P external delta V. W expansion is equal to minus negative by system. And boundary phenomena. What is work? Work is a boundary process and is an ordered form of energy transfer. Application of work when volume is changed. W is equal to minus P external delta V. Case 2 when temperature is changed. W is equal to minus integral of nRT delta T. Uh, Case 3 when Morse is changed. When Morse is changed, one goes into note. Delta Ng moles of product gas, moles of reactant gas. COCO3, CaO gives CO2. Delta Ng minus is equal to 1 minus 0 equal to 1. Volume contraction. This is a graph. Volume contraction. Work done A, B, C, D for clockwise is negative and ACW is equal to positive. Work graph W is equal to minus integral of V2 V1 P external delta V. W is equal to mod of W is equal to area under curve. Sign of W expansion में negative work compression में positive. Heat transfer, energy transferred between two bodies due to the temperature difference called heat. Energy transferred between two bodies due to the temperature difference is called heat. Unit of heat, SI, joule, CGS, urge. Heat cannot be stored. Heat is a random form of energy. It is a path function. When heat is transferred from system to surrounding, Q is equal to negative. When heat is transferred from surrounding to system, heat is positive. Energy U or E. System की खुद की energy. Internal energy does not include any energy arising out of interaction with surrounding. Example, gravitational energy. U ideal gas. K E is equal to ideal gas. 1. Delta U for isolated system, mass transfer, energy transfer. Delta U is equal to Q plus W. Delta U is equal to W. U is equal to 0 for isolated system. Okay. K, kinetic energy of one molecule 3 by 2 kT, kinetic energy of n molecules n 3 by 2 kT, kinetic energy of 1 mole 3 by 2 RT, kinetic energy of n mole molecule 3 n 3 by 2 RT. Internal energy changes when heat passes in or out of the system. Work is done on or by the system. Delta U is equal to Q plus W. Delta U is equal to internal energy. Q is equal to heat. W is equal to work. Thermal processes. Isothermal process, T is constant. Isochoric process, volume is constant. Isobaric process, pressure is constant. Adiabatic process, Q is equal to 0. Cyclic process, delta U is equal to 0. Entropy, enthalpy is equal to 0. Polytropic physics में. What is isothermal process? Temperature constant, delta UT is 0. According to first law of thermodynamics, 0 is equal to Q plus W, Q is equal to minus W. Heat given to the system is converted into work. Delta U isothermal process is equal to 0. Heat given to the system, Q is equal to positive. Delta U is equal to positive plus positive. Heat given to the system means compression work is equal to negative. Heat given to the system also. Work done is equal to negative. Heat lost by system, Q is equal to negative. Work done by compression is equal to positive. Wall should be thermodynamic. Wall should be diathermic. Isochoric process volume is equal to constant. Heat given to the system goes to internal energy. Internal energy. Volume constant. So U W is equal to minus P external delta V. Volume W is equal to 0. Delta U is equal to QV. Heat given to the system. Delta U is equal to Q. Delta U is equal to plus Q. T2 minus T1 is equal to greater than 0. T2 is greater than T1. Heat is given out. Delta U is equal to negative. T2 minus T1 is less than 0. T1 greater than T2 as delta U is equal to 3 by 2 RT delta T. Isobaric process, heat is used up to change the temperature as well as volume in such a manner that Tv remains constant for an ideal gas. Pressure constant, delta P is equal to 0, delta U is equal to Q plus W, PV is equal to nRT, P is equal to nRT TW. T1 by V1 is equal to T2 by V2. Cyclic process in which net change is 0 is called cyclic process. Change in the state will be 0. Delta U is equal to delta UG is equal to delta S is equal to 0. Delta S is equal to 0. WQC is not equal to 0. What is adiabatic process? Adiabatic process, Q is equal to 0. Delta U is equal to 0. Case 1. Case 1. Work done on the system. Work done on or by the system leads to the change in internal energy. Delta U is equal to positive W. T2 minus T1 is greater than 0. T2 greater than T1. Work done on the system under adiabatic condition increases the internal energy of the system. Work done by the system. Case 2. Q is equal to 0. Delta U is equal to W. Q delta U is equal to negative work. Work expansion is equal to negative. T2 minus T1 less than 0. T1 greater than T2. At a constant volume, heat absorbed by the system is equal to increase in internal energy At constant volume, heat evolved by the system is decreased in the internal energy of the system. Under adiabatic condition, work done by the system results in decreasing the internal energy. Cyclic process graph: AB isochoric heating, BC isothermal compression, CD isochoric cooling, DA isothermal expansion. Path of process: reversible is irreversible, non-zero external pressure, zero external pressure vacuum. Condition for reversible: path of process: reversible, irreversible, non-zero external pressure, zero external pressure vacuum. Reversible process: P external is equal to n plus 10, pressure दबा 8 atm, P gas is equal to 10 atm. P external is equal to 8 plus 1 9 atm, P gas is equal to 9 atm. 1 एक दाना और निकाल दो तो P external is equal to 7 plus 1 8 atm, P gas is equal to 8 atm. Each step can be repeated by reversing the process. Reversible processes are quasi-static in nature. It is an ideal pressure. It happens very slowly. It takes infinite number of steps. Both external and internal pressure changes but are always equal to each other. P external is equal to P internal. Equilibrium is maintained at every step. Work done isothermal is equal to nRT ln V1 by V2. Isothermal is equal to Boyle's law. W isothermal is equal to nRT P2 by P1 reversible. By Boyle's law, P1 V1 is equal to P2 V2. And there is a conversion 2.303 into log 10 base x is equal to log e x V1 by V2 P2 by P1. Irreversible work done. Intermediate expansion or compression. Free expansion. P gas is equal to 10 atm. P gas is equal to 10 एक पत्थर रख दिया ठीक है. एक्सपैंड करेगा पत्थर को फेंक दिया. ओके एक्सपैंड पत्थर को फेंक दिया. अच्छा फ्री एक्सपेंशन P ATM is equal to 1 ATM. P gas is equal to 10 ATM. अच्छा धीरे फास्ट प्रोसेस. P external is equal to 1 ATM. P ATM is equal to 1 ATM. P ATM अच्छा. P external is equal to P final. Condition for irreversible. P external is equal to P final. Condition for irreversible. Irreversible process for ideal gas. Steps can't be reversed. In reversible process, equilibrium is attained and every at final step only. P external is equal to constant. It is a very fast process. All real life processes are irreversible process. P external remains constant in irreversible process. Happens in finite number of steps. Work done by irreversible is a is a process in isothermal process. W is equal to minus integral of P external delta V. W is equal to minus P external V2 minus V1. W is equal to uh, एनआरटी P2 by P1 minus 1. ऐसे समय P1 equal to P2. एनआरटी V1 by V2 minus 1. Best example to study irreversible circuit. My power is equal to 40 kg. 5 kg का स्पीड है, 5 kg है, 40 kg पावर है। 5 kg को अगर उठाएंगे 40 तो स्पीड में उठाएंगे तो रिवर्सिबल प्रोसेस हो जाएगा। माई पावर इज इक्वल टू 30 kg है, 35 kg है। 35 kg को स्लोली, माई पावर इज 35 kg, 35 kg 35 kg में वजन है, तो स्लोली होगा तो रिवर्सिबल प्रोसेस हो जाएगा।